Okay, so now we are going to do problem 8. So it is the second example in our notes on page 7, as you can see at the bottom here. Okay, so we are going through the same steps as we did with the last example and as we've been doing so far this unit. So remember, first we need to factor the numerator and factor the denominator. So if I factor the numerator, I look for common factors between our terms. So x cubed and 4x both have an x in common. So when I factor that out, I've got x squared minus 4 left. Come back to that. Then I look at the denominator. And the denominator is 4x squared minus 8x. And I notice, oh, the 4 and the 8 both have a 4 in common. X squared and x both have an x in common. And what's left over? X minus 2. Now before we get too excited and move on, we have to look back at the numerator, and that x squared minus 4, that can actually be factored more. Now x squared is a perfect square. 4 is a perfect square, so that's what we call the difference of two perfect squares since we are subtracting them. So we take the square root of the x and write that twice in our two sets of parentheses. Square root of 4 is 2, so I know it goes 2 and 2. And then one of them is plus, one of them is minus. It doesn't matter which order that you go in for that. Just make sure you have an x plus 2 and an x minus 2. Denominator cannot be factored anymore. So then we'll go through our steps again. So first, our zeros, also known as our x-intercepts. And remember our zeros, we take every factor in the numerator, so on top, and set it equal to 0. So going through that, we have x equals 0. So unlike the problem before when we had the 3 all by itself outside of the parentheses, that 3 in problem number 7 did not have a variable with it. However, here we have a variable, so you have to set that equal to 0. Next one would be x plus 2 is equal to 0, and x minus 2 is equal to 0. When we solve for x, we see, oh, x equals 0. That was easy. Forgot to write that 0. So x plus 2 equals 0. When I solve that for x, I subtract 2 from both sides, and I get x equals negative 2. And then this last one, x minus 2 equals 0. I add 2 to both sides, so my final 0 would be x equals 2, since I'm adding 2 to both sides. Those are all of my zeros. Next step, we solve for the vertical asymptotes. Okay, so if I back up, the zeros are where my function will cross the x-axis. And so we do have a value on our function at those x values. So we do have an output for all three of those inputs is what that's trying to tell us there. Okay? Vertical asymptotes is when we set the denominator, all the factors in the denominator equal to 0. So we set 4x equal to 0, and we set x minus 2 equal to 0. Solving that, we divide both sides of this 4x equals 0, divide both sides by 4, and you get x equals 0. I have no idea why it's doing that. There we go. Okay, let me find my spot again. Here we go. Okay, sorry about that. And then the second one, so we have x equals 0 is 1 of our vertical asymptotes, which means our function will be undefined at a value of 0, x equals 0. And when I look at x minus 2, I solve that for x, and I get x equals 2. Okay. Our new step is to solve for poles. Okay. And looking back at our definition, don't be afraid to go back to your notes. we defined wholes as zeros of the numerator and of the denominator. So if we look at our zeros and our vertical asymptotes, do you see any that are in both categories? I don't know about you, but I see x equals 0. So that tells me since x equals 0 is both listed as a 0, a defined value, and an undefined vertical asymptote, that tells me we have a contradiction. So x equals 0, there will be a hole. And if we keep looking at our list, you should see x equals 2. Okay? It is both a 0, which means that tells us, oh, it's on our function, it's on our graph, it is defined. The vertical asymptote saying that that's equal to 0 or equal to 2, sorry, x equals 2, is saying, no, it's undefined. Again, those contradict each other. So we have second hole at x equals 2. So notice those both move over. So we're left with absolutely no vertical asymptotes here. Our third step is the horizontal asymptote. Now again, we look at the highest exponent in the numerator and our highest exponent in the denominator, so the highest powers in each. Okay? So in the numerator, I've got a power of 3, that exponent is 3. This is a 1, 3 is greater than 1, so I know the highest exponent in the numerator is 3. Going through the same process in the denominator, I have x squared and x to the first. So this x squared is the highest exponent in the denominator. So when I compare the top exponent to the bottom, I see 3 is the highest exponent in the top, 2 is the highest exponent in the bottom, and last time I checked, 3 is greater than 2. And if we look at our notes, look at the 3 cases, when our exponent on the top is greater than the bottom, we have no horizontal asymptote. Okay, there is no horizontal asymptote. So you will not need to draw that in because there is not one. Okay. Last step before we graph is the domain. Okay, and as always, it is all reals except for x equals any vertical asymptotes and anywhere we have holes. So x equals, well, we don't have any vertical asymptotes anymore, but we have holes at 0 and positive 2. So our domain would be all reals except for 0 and 2. Okay, so to graph this, I know my function will cross at -2, but to look at this further, I want to stop over at Desmos. And you may not have expected this kind of graph. We've got a line. Okay, so if we go back one more second to our notes and we look at the function after we factored it, you can see that we have an x on the top and an x on the bottom, and those will divide out. They are factors. We've also got this x minus 2 and this x minus 2, and those will also factor out. And then we're left with x plus 2 divided by 4. So when all of this is gone and you're left with x plus 2 divided by 4, you have a linear function. So your graph will look more like a line, okay? But it's always handy to check out the graph. So notice we've got a line. It appears to cross the x-axis at -2, exactly what we said, okay? But I wanted to draw your attention to our 2 holes, which we said were at x equals 0 and x equals 2. Just like before, notice no points come up at that intersection. And if I were to try to trace and find what happens at x equals 0. You saw it for a second there? I can go over it. Nope. So close. If it works out, it would say undefined there. Let me get back to this line. Okay, but it's not quickly finding that point for me. So I know that there is a hole, and it looks like it's approximately, right there, okay, 0. And you notice that point is an open circle. That's the hole, and that's how we identify the hole. But as you're approaching from the left and to the right, it looks like it's at a half. So when I go back to my graph here, I see that it will be at a point of 0, approximately 0.5. So you can use the graph to come up with that about halfway between this 0 and this 1, that's where I'll have a hole. Let me try to draw that a little bit better. Okay, so about at a half, that's where my hole is. And if we go back to the graph, I want to focus in on when x equals 2. So I'm just putting in what my hole was into Desmos, just type it right in. I created a new line, typed it in, x equals, and then what it was. Okay. And if I try to trace there, I can try to find the value. It won't give me a value because it's undefined. You could find that if you really got close there. But it looks like as I'm coming in from the left, so numbers less than 2, it's approaching a value of 1. And if I'm coming in from the right side and going down, getting closer and closer to an x value of 2, it looks like it's approaching 1. So at a coordinate of 2, 1, that is where my other hole will be. So I'll go right to, that's an x value of 2. And then at about 1, which let me get my red pen, there's another hole. Then as you can see from the graph, and if I zoom out a little bit, you can see it's just a straight line with those points. So do the best you can drawing a straight line. I'm not doing the greatest right there, but I've got my holes, which are just open circles, and I have my line that crosses the x-axis at -1, my 2 holes, one at x equals 0, x equals 2, and then it continues on. That is problem number 8, I believe, in your notes. Okay. The second one on page 7.